We're going to look at two different ways of doing example 7. One is the simplest way using our graphical calculators, but the second method is going to set up how we're going to solve problems in the next unit, in the next exercise. So let's do the simplest way, which is just using our graphical calculators to solve the problem. So we've got this random variable s, which follows a normal distribution with mean 127 and standard deviation 16. So remember, our second parameter, what I write here, is the variance. So the variance is 16 squared. Well, we want to find the 95th percentile of this distribution. So let's draw out a sketch of this S distribution. So we know that in the middle of our S distribution, we've got 127, that's the mean. And the 95th percentile is we want this point, let's call it C, on our distribution, where the probability to the right is 5%, 0.05. Equivalently, the probability to the left is 95%, 0.95. So we can solve this problem using inverse normal function on our calculator, because we've got some unknown value C and we know the total probability to the right is 5%. So if we go on inverse normal, we're going to put right as our tail because we know the probability to the right of our unknown value is 5%, so we'll put that as 5%. And our standard deviation is 16, so we put that in there. And our mean is 127. And we get 153 to three significant figures. So C must be 153. Okay. So we get the minimum is 153. Well, let's look at a slightly different method of doing it. And like I said, you wouldn't use this method unless you were forced to. But we are going to have to understand this method when we come on to the next exercise. So method 2 would be to standardize. So remember, we've got this problem where S follows normal distribution 127, 16 squared, and we want to find the probability of S being greater than some value C is equal to 0.05. So in this standardizing method, we want to try and turn this from a probability statement with S in it to a probability statement with Z in it, where Z is our standard normal random variable. So remember, in order to find Z, we take our normal random variable, we take away the mean of that random variable and divide by the standard deviation, which is 16. And in that case, if we do that, Z will follow a normal distribution with mean 0 and standard deviation 1. So let's take this probability statement here and let's try and get it in terms of Z. So what we're going to do is we're going to take away 127 from both sides of the inequality. And then we're going to divide both sides of the inequality by 16. So we've done the same thing to both sides of the inequality. So this is equivalent to what we had before. Well, the reason why we've done that is because this thing on the left, this random variable on the left, is our Z random variable, which follows the normal 0, 1 distribution. And let's leave this is just a value which we're trying to find. Let's leave it as it is, and we know that that's equal to 0.05. So let's draw a sketch of our normal distribution, because now we've got a probability statement about Z, and I'm not actually bothered about S. So let's draw out this Z standard normal distribution. So we know in the middle, the mean of Z is 0, and the standard deviation is 1. And we've got this this statement here, which says the probability of being to the right of this point, being greater than this point, is 0.05. So we know that this area here is 0.05. And the value that we need to be to the right of is this whole thing here. So that's C minus 127 over 16. That's that point there on our horizontal axis. So you used to have to use tables to find this value, but we can just use inverse normal on our calculator. So we've still got the right of our unknown value, has an area of 0.05, but this time, because we're thinking about this z distribution, remember this distribution is normal 0, 1, we're going to change the mean to 0 and the standard deviation to 1. And we get an answer of 1.645 to 3 decimal places. So we know that's equal to 1.645. So we can solve this in order to find out what C is. So we're basically just solving this equation now. So if we solve that, you will get C is 153 to 3 significant figures, which is the same as we got before from this method here.